So it's 7:05, so I will go ahead and start today's lecture. Just to give a rundown of today's class. So what we're going to be doing is we're going to be learning about trigonometry, and we will talk about trigonometry up until 7:45, and then for 5 minutes we're going to have a break. And then I think we're going to keep lecturing until maybe around 8:10ish, 8:10 to 8:15. During those 5 minutes, we're going to then switch to playing Kahoot. Okay, so today we're going to be focusing on chapter 18, which is an introduction to trigonometry. And the first section is going to be talking about trigonometry and right triangles. Okay.
Trigonometry.
Yes.
It's hard to pronounce, and it's even harder to get what it means.
Trigonometry. Yeah.
What does it mean?
Well, it's based off of roots, and well, trig is, I feel like that's related to triangles, because it's like the study. It deals with triangles a lot and like the ratio with triangles. So I don't exactly know like the literal translation of the word is, but yeah, I would say it's the study of, it's just the focusing of triangles and the different relationships that you can figure out between two triangles and ratios. Speaking of ratios, so there are three important ratios that you will deal with when it comes to trigonometry. And those are sine, cosine, and tangent. And sine is the ratio
cosecant.
We're going to deal with those later in the same, or I think in a different section, but we will cover those too. But first we're going to start with sine, cosine, and tangent. Okay, so sine is the ratio of the length of a leg opposite an acute angle of a right triangle to the length of the hypotenuse of the right triangle. To simplify the meaning of sine, for example, if we look at this triangle on the right, the sine of angle A, if we focus on angle A, the sine of angle A is, it first would be denoted as sin and then A, and sine of A would be equal to the length of the opposite A, so that would, in this case, it would be BC, or segment A, and that's going to be over the length of the hypotenuse, which would be AB, but you can also call it line C or segment C. Cosine is the ratio of the length of a leg adjacent to the angle to the length of the hypotenuse. So to again simplify this, to make it easier to understand, we would denote cosine to COS, and then we would put the angle right after cos. And then, but yeah, to simplify, to make cosine a little bit easier to understand, basically, if we were to figure out what the cosine of A is, we would look at cosine of A, and again, it's going to be the adjacent leg over the hypotenuse. So in this case, the adjacent leg would be B, and then the hypotenuse would be C. So cosine of A would be equal to B over C. And then finally, we have tangent, which is the ratio of the sine of the angle to the cosine of the angle, or the ratio of the length of a leg opposite an acute angle of a right triangle to the length of the leg adjacent. So for example, tangent would be denoted as tan A, if angle A was the focus angle in this case. And you can write it as sine of A over cosine of A, or you can write it as the adjacent leg over the opposite leg, yes. So if we were trying to figure out what tan of A was, adjacent leg would be SOHCAHTOA. Oh wait, sorry, it's opposite. Sorry, it's opposite over adjacent, not adjacent over opposite. My bad. But in this case, the opposite leg would be A, and then the adjacent leg would be B. And if you were to simplify sine of A over cosine of A by plugging in the values that you got for sine of A and for cosine of A, so that would be AC and BC, that would simplify and you would eventually get to AB. So either way works. But yeah, so that's sine, cosine, and tangent. This, I would say geometry does introduce you to these ratios, but then you go into it a lot deeper in pre-calc, or if you end up taking trigonometry, the class itself. So yeah, okay, I'll leave this up here for a few seconds, or just so that you can review the information, and then we can go to the next slide.
I still don't get what's the definition of trigonometry.
Trigonometry. Okay, if you want, here, I will search up the internet. The internet definition, it says that it is a branch of mathematics that studies relationships between side lengths and angles of triangles. So I would say, yeah, it's just, it deals with triangles a lot. Like, just that's the most, in general, I would say it deals with, yeah, triangles. But then if you want to be a little more specific, it studies like the ratios between the side lengths and like the angles. And as you can see, we just dealt with side length ratios with sine and cosine and tangent. So yeah, if you see the word trigonometry, just think, okay, this is going to be about triangles and the relationships between, you could say, like different side lengths, angles, and yeah.
Can we just call it
Trig. You can shorten it, yeah, to trig too.
Trig.
Okay. Yes. Okay, I'll go ahead and go to the next slide.
And do you have quad?
Do I have what?
Like, why is it only trigonometry and not like quadrinometry?
Because, well, I think it's, for one, trigonometry doesn't deal with quadrilaterals and stuff, I think.
Oh, I know SOHCAHTOA. Oh, I know
Yeah.
SOHCAHTOA.
Yes. So sine, cosine, and tangent are examples of trigonometric functions, and problems that involve trigonometric function as an area of math is known as trigonometry. So one way to memorize the ratios that we just went over, we can use the mnemonic SOHCAHTOA phrase. So SOHCAHTOA, that stands for sine, and then that's going to be equal to opposite over hypotenuse. So you can see SOH. Cosine is going to be equal to adjacent over hypotenuse, so that would be CAH. And then finally, tangent would be equal to opposite over adjacent, so that's TOA. So yeah, this is actually a really useful way to memorize these different ratios. Okay, I will go ahead and go on to the next slide. Of course, we can go back to these slides if you need a review over any of the stuff that we just covered, because we have a problem to go over next. So this problem is going to be dealing with what we just learned. So we want to find the sine of 45 degrees, cosine of 45 degrees, and tan of 45 degrees, or tangent.
Can we go back to the notes that explains all of this?
Yes. Do you want to go back to this one?
Yes.
Okay. For those who just need to know what the problem is focusing on, you wanted to find, yeah, you just, okay. You're given a 45, 45, 90 degree triangle, and then you wanted to find the sine of 45 degrees, cosine of 45 degrees, and tangent of 45 degrees. All right, are you good, Kessler? Can I go back to the other slide? Kessler?
Yes.
Okay. All right. Okay. I'll give you guys a few more seconds and then we can go over it. Okay. So on the right, we have a 45,
To
45.
remember this, but whatever.
Yes. Wait, what did you say?
Basically, you're supposed to memorize.
Oh yeah, this is eventually going to be very important. In for example, my pre-calc class, I had to memorize this information, but I did not have to memorize this in geometry, so I think it's a little bit more lenient. But yeah. Okay, so on the right, we have a 45, 45, 90 degree triangle, ABC with the right angle at C. And the ratio of a leg of the 45, 45, 90 degree triangle to its hypotenuse would be 1 over square root of 2, because if we were to say that the legs were equal to 1, then that means that the hypotenuse would be equal to 1 square root of 2. So then the ratio would be 1 over square root of 2. So then we would have the following. Sine of 45 degrees, which would be equal to sine of A, would be equal to BC over AB, and that would be 1 over square root of 2. And if we were to simplify the radical expression, we would eventually get square root 2 over 2. Similarly, we also have cosine of 45 degrees, and if we were to figure out what cosine of A was, because A is equal to 45 degrees, that would be AC over AB, and then that would be equal to 1 over square root of 2, and we get the same answer, square root of 2 over 2. And finally, because the legs of the 45, 45, 90 degree triangle have the same length, we have the following. So tan of 45 degrees, that's going to be tan of A. Remember, tan can be sine over cosine. And since, we're dealing with division right here, so sine of A divided by cosine of A, they would eventually cancel out. So then you would eventually get 1 as your answer. Or you can just say, tangent is equal to opposite over adjacent, and that's a BC over AC, so that would be equal to 1. Okay, I'll leave this up here for a few seconds, and then we can go ahead and go to the next slide. But yes, SOHCAHTOA, very important. I would get that down. But SOHCAHTOA is, I would say, pretty, I think it's a catchy mnemonic phrase, so I don't think it's the hardest thing to memorize. Okay, I will go ahead and go into the next slide. Okay, so this slide is going to be talking about the sine, cosine, and tangent for 45, 45, 90, and 30, 60, 90 triangles. So the table shows the sine, cosine, and tangent values for the 45, 45, 90, and 30, 60, 90 triangles. The triangles below show the relationships among the triangle sides that we use to find the values. So if we look at our graph here, or in our table, you can see that the angle measurement is pictured on the left, and then we have the values of, for example, sine of 30, cosine of 30, and tangent of 30 in the first line, and so on. So you might notice that there is a pattern, especially when it comes to sine and cosine. For example, sine of 1/2 is 30, or sine of 30 degrees is 1/2, but then a cosine of 60 degrees is 1/2. And you can see that, the values are kind of flopped. But yes, these values are actually, as Alvin was saying, you need to, eventually you're going to have to memorize these values, I would say, especially when you take trigonometry or pre-calculus, because you're going to be using these values a lot. Yeah. My teacher, for example, she gave me timed quizzes where I had to like answer, oh, what's the sine of certain number of degrees, and like in 10 seconds, and then she would like display like the next problem. Like it was just really intense, but yeah. So I don't think you have to get these values down just yet, but when the time comes, you definitely should be able to get the values. You should just be able to pull them right out of your head. Okay, I will go ahead and go on to the next slide. Oh, here, let me fix it so that I don't display the solution right off the bat. Okay, there we go. And I'll leave the triangle up there. Okay. And just for that, well, it's actually, I would say it's not part of the problem. It's just on the side note. Okay, so in triangle PQR, we have angle P equaling 90 degrees. PQ is equal to 3 and QR is equal to 7. First, find sine of Q and cosine of R. Then find tangent of Q. And then finally, find sine R squared plus cosine R squared.
I just wanted to mention something.
Yes.
So like the sine of an angle squared plus cosine of the angle squared is always 1.
Yes, that is true. So that just, yes, that gave away one of the answers. But yes, that is always going to be true. Cosine squared plus sine squared is going to be 1. And we are going to cover those, I think we covered, yeah, we definitely covered that and then something else. But there are equations of trigonometry too. But yes, we will make sure to go over those. Okay, I realized that they gave you the length of PR, but that's okay. But basically, first we're going to be dealing with, I think, yes, we find sine of Q first. But if you didn't know this value, this wasn't supposed to be up here, but it was. But you would use the Pythagorean theorem to determine that PR is equal to 2 square root of 10. And then once you figured that, you would have drawn a diagram or triangle like this, and we would then have the appropriate values needed to figure out what sine of Q is. So sine of Q, that's going to be opposite over hypotenuse. So that's PR over QR, or 2 square root of 10 over 7. And then cosine of R, that's going to be adjacent over hypotenuse. So that's PR over QR, or that should say 2. 2 square root of 10 over 7. So that was pretty straightforward. Okay, and then next we have tan of Q, so that's going to be adjacent over, oh no, wait, no, opposite over adjacent, sorry. So that would be PR over PQ, and that would be 2 times square root of 10 over 3. And as Alvin said, to basically sine R squared plus cosine R squared is always going to equal 1, but since we haven't exactly covered that yet, the problem just wanted you to just figure it out without that knowledge. But in order to figure it out, first you would find sine of R, but we already did that. Oh no, sorry, we did not. We found sine of Q. But sine of R, that would be opposite over hypotenuse. So that's going to be PQ over QR. And then next, we would eventually find cosine R, and cosine R is going to be adjacent over hypotenuse, so that's going to be 2 square root of 10 over 7. And eventually you would plug in the values that you know, so you would get 3 over 7 squared plus 2 times, or 2 squared of 10 over 7 squared. And that's going to be 9 over 49 plus 40 over 49, and you would eventually get 1. And then this is just a side note, but usually when we square the trigonometric values or the ratios, it can be sine, cosine, tangent, and then we're going to cover 3 other trigonometric ratios.
Can I mention something also?
Yes.
So the thing is, like, first we can also find sine 90 degrees. Sine 90 degrees, sine is opposite divided by hypotenuse. Hypotenuse, the opposite of 90 degrees is the hypotenuse. So the hypotenuse divided hypotenuse is 1. So sine 90 degrees is 1. And then the second thing, to find cosine 90 degrees, we can use sine squared plus cosine squared always equals 1 to find that cosine 90 is 0.
Yes, we are also going to go over those values, but yes, thank you, Alvin. Yeah, as a side note, when you're squaring these ratios, you would put the 2, or if you're cubing them, you put the 3. Basically, you put the power in between the the word sine, cosine, or the abbreviation of the ratio, and then what would follow it would be the angle measurement. So in this case, it'll be R. But yeah, so if you see a number in between that, just saying, for example, this would be sine R squared, and this would be cosine R squared. So yeah. Okay, I'll leave this up here for a few more seconds because I feel like I explained a lot and then I gave you time to look over it, and then we can go on to the next slide. Okay. So next we have trigonometric identity. Okay, so equalities that involve trigonometric functions are just that there should be no and, are true for every value of the occurring variables where both sides of the equality are defined. So we have 2 trigonometric identities for an acute angle A. So as Alvin previously said, sine A squared plus cosine A squared would equal 1. And then we have another one where sine A is equal to cosine of 90 degrees minus A. And we saw this previously in the chart that we dealt with. So if we want to go back to this chart right here, let's say we had, we can say sine of 60. So sine of 60 would equal cosine of 90 degrees minus 60, which is cosine of 30. And if you look at the values, that is correct. We have square root of 3 over 2 for sine of 60, and then square root of 3 over 2 for cosine of 30. Okay. And so if you come across the word trigonometric identity, just think that, that's going to probably involve, I would say, like equations, formulas. Yeah, there's actually quite a few of them, which you also have to memorize, or I at least had to memorize. I had a friend who said that he didn't have to memorize them. I'm very lucky of him, because there are a lot, and you can get confused with them if you don't memorize them carefully. But yeah, but for now, we're just going to be dealing with these 2 identities. And we can, of course, go back to these slides when we need to, if we're solving a problem. Okay, I will go ahead and go on to the next slide, which is an important slide. If angle A is acute, then 0 is less than sine of A, which is less than 1, and 0 is less than cosine of A, which is less than 1, and tangent of A is greater than 0. I would say this is pretty straightforward. So far we have, I don't think we've dealt with obtuse angles exactly yet for the trigonometric ratios, but when it comes to, yeah, this is just straightforward, I guess, but sine of A and cosine of A, they're going to be between 0 and 1, and then tan, because that's going to be ratio of sine over cosine, that means that tangent will always be greater than 0, because sine of A and cosine of A are always, they're going to be positive. But as Alvin was saying, once we get to 90 degrees, things get a little bit different. Sine of A at sine of 90 degrees equals 1, and then cosine of 90 degrees equals 0. But we will also go over that in upcoming slides. Okay. So next we have problem 18.8, where we want to find AC and BC to the nearest tenth. Or if you just want to say, oh, you're supposed to multiply, like, one value and then another value, you can also say that. You don't have to, if you don't have a calculator with you. As long as you understand what you're doing and you get the concept, I would say that's what the most important thing is. But yeah.
So to do this sine stuff, we can use a calculator, right?
Yes, if you want to use a calculator, you can do that.
I don't think it's 1/2 because I don't think you can solve the sine of any like random angle without using a calculator.
Yeah, it would be quite difficult.
Find an AC and BC to the nearest tenth.
Okay, I will give you a few more seconds and then we can go over it. Okay. All right. So first we're going to find AC. And we're going to use the values that we know for the triangle to figure out what AC is. So we know what angle C is, so I would say that we should focus around angle C. But to make sure that AC is included in the ratio that we're going to set up, we're going to choose sine, so that we would get sine of C is equal to opposite over hypotenuse, or AB over AC. So that would mean that if we were to isolate AC, that eventually equal AB over sine of C. And sine of C is going to be equal to sine of 59 degrees, and that is going to be equal to approximately 0.857. So then AC would be equal to AB over sine C, and we just plug in values to get 14. And then for BC, we can use Pythagorean theorem or trigonometry, since we know what two side values are now. But since we are talking about trigonometry, let's go ahead and use trigonometric values. So in this case, we're going to use cosine of C, because cosine of C is going to be adjacent over hypotenuse, or BC over AC. So if we were to isolate BC, that would be AC times cosine of C, and C equals 59 degrees. So then we would get cosine of 59 degrees. That would be equal to 0.515, and eventually BC would equal 14 times 0.515, which is 7.2. Okay, I'll give you a few seconds to just go over the information, then we can go to the next slide. Okay. So next, so as Alvin said previously, we have more trigonometric functions to go over, and those are going to be cosecant, secant, and cotangent. So cosecant is going to be denoted as CSC, secant is going to be denoted as SEC, and cotangent is going to be denoted as COT. So cosecant of x would equal the reciprocal of sine of x, or 1 over sine of x. Secant of x would equal 1 over cosine of x, and then cotangent of x is equal to 1 over tangent of x. So basically, these three trigonometric functions are reciprocals of the previous three functions that we were talking about. In order to figure out which trigonometric function is the reciprocal of the three functions that we just learned, this is what I learned from my math teacher. But if you look at the third letter of each of these trig functions, so for example, if we look at cosecant, there's an S, so that's going to be the reciprocal of sine. If we look at secant of the third letter, that's C, so then that's going to be the reciprocal of cosine. And then if we look at cotangent, the third letter is T, so that's going to be the reciprocal of tangent. So I thought that was a very efficient way to remember the reciprocals. So yeah, I think that helps with the memorization of it. And I'll give you a few more seconds to just go over it, and then we can go ahead and move on to the next section. Okay. So next we have 18.2, which is titled Not Just for Right Triangles. Okay, so this is an important slide. But basically, we're going to let point A equal 1, 0 in this image on the right, and point B is going to be on the unit circle. The unit circle in math is just a circle where the radius is equal to 1. But to keep going on with the example, so we're going to let point B be on the unit circle so that B is x degrees counterclockwise from A. Then we would define cosine x and sine x to be the x and y coordinate values of point B. So when we're dealing with the unit circle, the points that are going to be on the unit circle, they're always going to be cosine x and sine of x. And cosine is always going to be the x value, x coordinate or x value, and sine of x is always going to be the y value. So if we look on the right, point B is on the circle, and it's 60 degrees counterclockwise from 1, 0. So by drawing BP, we can form a 30, 60, 90 degree triangle BPO, so that PO would be 1/2, and BP is square root of 3 divided by 2. Because we know that the hypotenuse is 1, the shorter leg is going to be 1/2, and then, yeah, we have, because the shorter leg is 1/2, that means that the longer leg would be 1/2 times square root of 3, or square root of 3 over 2. Okay, so then that means that point B is going to be equal to 1/2 comma square root of 3 over 2. So cosine of 60 degrees, which would be the x value, is going to be 1/2, and sine of 60 degrees, which is the y coordinate, is going to be square root of 3 over 2. And note that these values correlate to the table that we previously went over. Give you a few more seconds to go over it. Okay, we can of course always go back to this slide when we need to just go over information. So next, did I display the answers again? Yes, I did. Okay, hold on. Let me make sure to, okay, that should fix it. Okay, so in this problem, we want to find the values of cosine of 150 degrees and sine of 150 degrees. Don't be tempted to use a calculator because you could solve this just by plugging in the values, but in order to just figure out, to understand the relationship between the unit circle and then, being able to draw out that triangle, and then figuring out the cosine and sine values based off of that triangle that we drew out, I would recommend doing it the longer process that we just went over. But yeah, just don't be tempted to put those values into your calculator. Okay, I will go ahead and go over these problems. And then I think once we're done with this problem, we could take a break. Okay, so first we're going to let point A equal 1, 0. And then we're going to let point C equal the point on the unit circle that is 150 degrees counterclockwise from A. So then this would mean that the coordinates of C, that's going to be cosine of 150 degrees, because cosine is always going to be the x coordinate, and then we'd have sine of 150 degrees because sine is always the y coordinate. So in order to determine the coordinate values, we're going to take some steps. So first, we're going to figure out where point C is on the unit circle. And we can see that C is on the minor arc from 0 to 1 to -1, 0, or quadrant 2. This is really important. We're going to be going over the quadrants too, and the signs that correlate to cosine and sine. But remember, because we are on the negative side of the x value, that means that cosine will be negative. But then because we are on the positive side of the y coordinate, or the y values, that means that sine would be positive. Okay, so then if we continue on with figuring out how to solve this problem, by building a right triangle, we can see that angle AOC is 150 degrees, and you also could have probably figured that out after just reading the first, or going over the first part of the problem. So then that would mean that angle COP is 30, and triangle COP is a 30, 60, 90 degree triangle. And because we know that OC is equal to 1 and angle COP is 30, OP is going to be equal to the square root of 3 over 2, and CP would be equal to 1/2. there are different ways you could solve this. You could have used the trigonometric functions by plugging in, like like sine of 30 or cosine of 30 or something. You could plug in the angle value and then the trigonometric functions, or you could remember that the different relationship side length values between a 30, 60, 90-degree triangle. Like, okay, if the hypotenuse is equal to x and that's equal to 1, then CP of the shorter leg is going to be x over 2 or 1/2, and then PO would be it would be equal to the shorter leg 1/2 times square root of 3, or so then that would be square root of 3 over 2. So yeah, you could arrive to these two values in different ways. Finally, because C is to the left of the y-axis and above the x-axis, its x-coordinate is negative, while its y-coordinate is positive, as we previously talked about when we were going over quadrant 2. So C's coordinates would be negative square root of 3 over 2, 1/2, meaning that cosine of 150 degrees is negative square root of 3 over 2, and sine of 150 is 1/2. Okay, so I'll leave this up here, but we can go ahead and take a 5-minute break. It is currently 7:46, so we will start back up at 7:51.
When are we gonna do a Kahoot?
We will do a Kahoot. We'll start it probably between 8:10 and 8:15. I'd say, or maybe 8:17. We will see. But of course, we will do a Kahoot. It'll just be at the end of class. Okay, so it's 7:51, so I will go ahead and go back to the lesson. Okay, so we're going to just keep expanding on the concepts that we were talking about earlier with the unit circle. But again, the unit circle is a circle of a unit radius, or that is a radius of 1. And the values of cosine x and sine x are shown to the right. And notice the different positive and negative signs, and these are based on the quadrant that we are focusing on. Okay, so these values that you see all around, you will have to memorize these. I created flashcards, but you will notice that there is a pattern, and we have gone over that pattern with the first quadrant when we were going over the table. But yeah, so this is a very it is very important concept in pre-calc, trigonometry. So yeah, but it's pretty straightforward too. The values, once you get them down, I would say you got them down. It's not like there's any exceptions or anything like that with the unit circle. But yeah, and of course we can always go back to this slide. Yeah. Okay, so we can go ahead and go on to the next slide, which just talks about the different sign values, or the different positive and negative values for the x and y coordinates, or cosine and sine. So I feel like you learned about the quadrants and maybe pre-algebra, algebra, I can't remember, but the quadrants are very important when it comes to determining the signs of the x and y values. So in quadrant 1, both values are going to be positive, but then in quadrant 2, it's going to be negative positive. Quadrant 3, it's negative negative, and quadrant 4, it's positive negative. So depending on where the angle is, so let's say if it was angle 300, if the angle was 300 degrees, that's going to be quadrant 4, because this is 0 degrees, this is 90, this is 180, and this is 270. So 300 has to be between 270, and you can say this is 360. So yeah, 300 has to be between 270 and 360. So that would mean that its coordinates would, or cosine of x would be positive, or cosine of 300 is positive, and then sine of 300 is negative. And as you can see here, these are the different positive and negative values for these 6 different trigonometric functions. This might seem like, oh, you have to memorize all of these, but you actually don't have to. It's just showing the different signs for each function. Basically, in the first quadrant, we're going to have all of them as being as positive. But then in the second quadrant, sine and then cosecant would be positive. Remember that cosecant is 1 over sine. So if sine is positive, then cosecant is going to be positive. But then cosine is going, and cosine and secant are going to be negative, because if cosine is negative, then that means that secant has to be negative, because remember secant is 1 over cosine. And then finally, tangent and cotangent are going to be negative, because tangent is cosine over sine. If you divide a negative over a positive value, that means that your overall value would be negative. So then you would tangent would be a negative value, and then cotangent, because cotangent is equal to 1 over tangent, it's going to also be negative value. And then down here below, because sine and cosine, they're going to both be positive, so their reciprocals, cosecant and secant, are going to be negative. However, when it comes to tangent, because tangent is equal to cosine over sine, that would be negative over negative. That would end up as being positive. So then tangent and cotangent are going to be positive in the third quadrant. And then finally, in the fourth quadrant, we're going to have cosine being cosine and secant being positive, sine and cosecant are going to be negative, and then tangent and cotangent are going to be negative. Again, tangent's going to be negative because you're dividing sine over cosine, which is negative over positive. So that would end up, tangent would end up equaling a negative value, and then same thing with cotangent. So you don't have to memorize the different signs. You can figure them out based off of where the point is located at, and then knowing the different relationships between these 6 trigonometric functions, you can figure out, oh, tangent's negative, or oh, cosecant's positive. Okay. Of course, since we're just learning about this, I mean, if unless you're like a math prodigy or something, if you can't, well, I think the signs are pretty straightforward, but I mean, just cosine, sine, tangent. I don't expect you to just remember exactly like everything clearly, but at the same time, unless you guys are, really good at math and really strong, and you just pick up information really quickly, then that is great, and that would be really good if you can remember the different trigonometric functions and then the signs. Okay, I will go ahead and go to the next slide, which talks about a curious pattern. So notice the curious pattern emerges when we put the values of sine and cosine from 0 degrees to 90 degrees together. So you can see that under the square root, the number is increasing by 1, and then that's for sine, and then for cosine, the number under the square root is decreasing by 1, and you can just see the relationship that these 2 trigonometric values hold, and they're just they're backwards, I would say, because one is they're inverse of each other in a certain aspect, because as one is increasing, one is decreasing, but then as one is decreasing, one is increasing. Okay, we can go ahead and go on to the next slide. So this slide, there is another formula for figuring out the area of a triangle, and this deals with trigonometry. That's why we haven't covered it before. But if we're going to let BC equal A and AC equal B in triangle ABC, we should have the following. So then the area of triangle ABC is going to equal 1/2 times A times B times the sine of C. Note, for example, when I was taking the ACT, there is trigonometry and pre-calc included on the ACT, but this, I can't remember if this formula came up. There is another formula, or it's called the law of cosines, which we will go over eventually. That came up, but it just came up as in the equation was there, and then it was just the values plugged in. You actually didn't need to calculate the entire formula. So it's just important to know that these formulas exist for the ACT, and you just know where the values go in and how you plug them in. But then when it comes to your regular, the class that you go to, you should get these formulas down, I think. Or it depends on your teacher. Again, if your teacher's nice, they might just let you write the formulas down on like some kind of paper, and then you can use it while you take a test or something. But my teacher forced us to memorize these formulas. Okay, so next we have our last section, which is 18.3, which deals with the law of sines and law of cosines. And I previously talked about the law of cosines, but all right. So we're going to start this section off with problem 18.19. So in triangle ABC, AC equals 15, BC equals 12, and angle C equals 34 degrees. Find AB. Okay, so let's go ahead and go over this problem. So we can set up the triangle like the one shown to use trigonometry to find AB. So first, we create triangle BCX with the 34-degree angle as one of the acute angles. From triangle CBX, we're going to focus on angle C, and we're going to say that sine of C is equal to BX over BC. And since we know sine of 34 is, we can just plug that into a calculator and we would get 0.559. So that would mean that if we were to isolate BX, that would be 0.559 times BC, and we just plug in 12 to get 6.71. And we also have CX over BC, so that's adjacent over hypotenuse. That's going to be equal to cosine of C. And again, we can use our calculator to figure out what cosine of 34 is, and that's 0.829. So then if we were to isolate a CX, we already know what BC is, we would plug in 12, we would eventually get CX is equal to 9.95. And we don't know AB yet, but now we have the length of one of triangle BXA's legs. If we can find the other leg's length, we can use Pythagorean theorem. Fortunately, XA is simple to figure out because we can just use simple subtraction because XA is equal to AC minus CS, which is 5.05. This means that we can use Pythagorean theorem to solve for AB, and that would be equal to the square root of BX squared plus XA squared. And finally, we would get 8.4. So notice how we use trigonometry to identify the different values that we didn't know, so then eventually we can get to the value that we wanted to figure out. But I mean, this is kind of a repetitive, I guess it's a repetitive, I'm forgetting the word, pattern of problem solving in geometry, where you're given values and then you work your way to eventually get to the value that you want to figure out. Okay. So next we have law of cosines. And law of cosines states that if we let A equal BC, B equal AC, and C equal AB in triangle ABC, then the law of cosine would be equal to C squared plus A squared plus B squared minus 2AB times cosine of C. This might seem like it's a lot, but it's just a formula where you plug in the values that you know and then you solve for the one value that you don't know. So yeah, it literally is just plugging in and then solving for the one value that you don't know.
The law of sines is way easier.
Yes, law of sines is much easier. But yeah, this is the law of cosines. Again, it might seem threatening, but it actually really is not. Okay. And of course, we can go back to this slide because we have a problem next. So we're going to let PR equal 12 angle QPR equals 66 degrees and angle PRQ equals 63 degrees in triangle PQR. We want to find PQ and RQ. Okay, I will go ahead and go over this problem. So what we're going to start with is we're going to start by building a right triangle because we know how to use trigonometry to find the side lengths of a right triangle. So from right triangle PTR, we're going to solve for, we're going to have angle R be our focus angle because we know what the value of R is. So we're going to get sine R is equal to PT over PR, opposite over hypotenuse. So PT would be PR times sine of R, and that would be equal to 10.69. We also get cosine of R is equal to TR divided by PR, adjacent over hypotenuse. So TR is going to be equal to PR times cosine of R, which is 5.45. And now we're going to use a right triangle PQT to find QT and PQ. First, we're going to find angle Q, and that's going to be equal to 180 minus 66 minus 63, which is equal to 51. We have PT over PQ equals sine Q. So that's going to mean that PQ is equal to PT over sine of Q to get 13.6. Again, all of these deal with just plugging in the values that we already know, and then isolating the one value that we want to get. We also have PT over QT equal tan Q. So QT is going to be equal to PT over tan Q, which is 8.66. And finally, we're going to get the following, where QR is going to be equal to QT plus TR, which is 14.1111, or 14.11. So that will be our final answer. Okay. All right, I'll go ahead and go to the next slide, which deals with law of sines. And as Alvin said, a law of sines is a lot easier compared to law of cosines. So if we let A equal BC, B equal AC, and C equal AB in triangle ABC, C should be capitalized, the law of sines states that A over sine of A is equal to B over sine of B, which is equal to C of sine over C. So you can see they're just ratios, and yeah, it's pretty straightforward. So A would be sine, A would be A over sine of A. You can see that they're just opposite side and opposite angle. That's going to be equal to B over sine of side opposite angle, which is equal to sine of C, or C over sine of C, which is opposite side opposite angle. And this is actually very useful when you know an angle and then its opposite side. And then you know another's, you can know either another angle or another side, but you don't know that other angle or side. You can use law of sines to figure out what that one missing value is. And we're actually going to use law of sines in the next problem. Okay, and we can go back to this slide too. So in problem 18.23, we want to find BC, CD, and BD. Okay, I'll go ahead and go over this problem. Okay, so we know two side lengths and the angle between these two sides, so we can apply the law of cosines to find BC. So BC squared is going to be, if we look here, it's going to be 8 squared times, or no, 8 squared plus 12 squared minus 2 times 8 times 12 times cosine of 66 degrees. As you can see, we're just plugging in numbers. So we're plugging in 8 squared. We're plugging in 12 squared minus 2 times 8 times 12. We're plugging in 8 and 12 again. And then cosine of 66, we're plugging in 66 degrees. If you practice law of cosines, you're eventually going to get comfortable with plugging in numbers. At first, it might just look a little bit threatening, but it is a lot easier than it actually looks to be. So eventually, you will get to 129.9. So BC would be equal to 11.4. Turning to triangle BCD, we got angle BCD, which is equal to 180 minus 65 minus 85, which is 30 degrees. So we now know a side length and all the angle measures of triangle BCD, so we use law of sines to find the missing side lengths. And this is where I would say it's simpler compared to the other, compared to law of cosines. So we have BC over sine of D is equal to BD over sine of angle BCD, and that's going to be equal to CD over sine of CBD. So this means that we have 11.4 over sine of 65 equal to BD over sine of 30 equal to CD of sine of 85. To solve for BD, we have BD equal to 11.4 divided by sine of 65 times sine of 30. So as you can see, we just took the first two parts of this equation, because you don't necessarily need to have actually 3 different ratios. As long as you have 2 ratios for law of cosines, then you can use it to figure out one value that you don't know. So in this case, yeah, we just took the first 2 ratios that we established to get 6.3, and then solving for CD gives us the following. So CD is going to be equal to 11.4 divided by sine of 65 times sine of 85, and that's going to be equal to 12.5. Okay, so that was actually the end of this chapter. So we can go ahead and play.
Our Kahoot.
Yes.
Did you create a play for Kahoot?
Oh, I need to log in. Let's see. Wait, what did you say?
I was asking Kessler, did you come here to play Kahoot?
Oh.
No, I did not come here to play the Kahoot. I didn't just come here to play the Kahoot. I came here to actually find me myself, get myself entertained. Well, not exactly entertained, but I'm just saying I've been a little bit bored, so I feel like this would be a good course for my brain.
This world is full of weirdness.
Just like you.
Just like you.
Gatling P2000. That's from. I always see Plants versus Zombies, right? Tesler.
Because mostly it's just mostly the 2000 that's important.
Ah, okay. Is Kessler going to be the only one who's playing? Hi. Okay.
I'm thinking of a name.
You're thinking of a name? KK. Oh, hi left.
Maybe he just changed his name.
Who?
Oh,
Who?
he's back.
The hi guy. Oh, now he's back.
Are you in, Alvin?
Almost. I'm just thinking of a name.
Joe Biden. Nice.
Joe Biden.
Elika's like our reigning champ. She's like won quite a few of these games.
Actually, okay, Gatling P 2000 and KK are both me.
Okay.
Yee. So basically now all I need to do is just add my combined scores.
Hailstorm.
You didn't even spell kale right.
Oh, sorry.
You didn't even spell kale storm correct.
Whatever. Now I left.
Oh, now you're back.
And you still and somebody still spelled it wrong.
Okay, I'm going to start the game soon. Just warning.
Wait.
Anonymous. Okay. Are we good?
Yep.
All right, starting the game.
Yep. Ready.
Review 5. The small square side length equals 3. The larger square side length equals 7. Find the area of the shaded area.
Oh my gosh. Whoever gets this wrong will be grounded for a century.
A century?
You'd be dead by then.
You can skip once there are 5 answers because there's only 5 players. No, 6. And 1 person got it wrong. And 6 players. 6 players. 6 players.
A circular spinner has a radius of 10 centimeters and 5 chance of the spinner landing on wind. Find the wind section area.
Whoever gets the question wrong will be grounded for 2 months.
Whoever gets the question wrong will just have to be faced by Alvin.
Okay.
And apparently half the people are going to be grounded for 2 months.
A triangle's hypotenuse equals 6 squared in one angle equals 40.
Oh, that's inches. Sorry. IN says for inches and one angle equals 45 degrees.
6 square inches. Is 6 square inches in one angle is 45.
Whoever gets this question wrong is going to be grounded for 5 seconds. Whoever gets a question wrong can be ground for 2.
Stop. DC is twice the length of BD. Find the area of triangle ABC. In the right triangle, the two legs have a length of 40 and 42 inches. What is the triangle's area? Only a few seconds left.
Well, now we got. Oh, I'm 1 point behind the first.
Multi-select.
Multi-select. It should not be multi-select. Oh, no.
What is the total area of the non-shaded region?
What? There's only one answer.
There should be only one answer, but I think I forgot to deselect one of the answers, so people are going to get credit. But it's okay. All right. So you have a greater chance of getting more points. Even so.
Just choose all the answers.
Just choose all of the answers.
Yeah.
Or do you guys want me to skip the question?
No, don't.
No?
Wait. No, skipping just gives all the people. Skipping still gives points. Oh, 8 people now.
Oh, wait, why was it multi-select?
Who knows?
Because it was not multi-select. Okay. Oof.
3 identical squares are lined up to form a rectangle with a perimeter of 104 degrees. What is the area of each square?
The in stands for inches again, but you don't have to.
So, this is confusing.
First answer.
First, the answer doesn't mean you technically get it right.
That is true.
Now I have three cahoots.
Oh my god.
I am Gowling P2000, KK, and Oof now. So all I need to
What
do
does
now
that mean? You have 3 names?
Yep.
Wow.
So that means after this I get to add up all the points, so that's my final score.
No, you cheater.
How am I a cheater?
Because you use multiple. You can. I
So
can
is
only.
that be cheating? What's the area?
I can only count you as not cheating if you just choose the highest score. I can let you choose the highest score in the end. But I have something to say.
Mm-hmm.
I think it is not possible to find the area of the triangle because it didn't say it was a right angle.
Even though it showed an right angle, that doesn't mean it has evidence to say that it is.
Yeah, it does have evidence.
It is okay. It has a height, so even though the height's like outside, there is still a height to the triangle.
But it's not. But it may not be in right angle, so you can't prove it's a height.
Or okay, the formal definition of a height, I can't exactly remember, but it's supposed to be, yeah, it's basically supposed to be the length from the bottom length, or in this case, we can say the bottom leg to the very top. And even though the height of it is shown on the outside here, it still is the height of the triangle.
Up.
So, yes, okay.
KK, oof. Point zeros in the center of the circle circumscribed by triangle ABC. What's the degree of the measure?
I'm just looking at the picture, you know.
ABC. Degree 3, 80, 60.
Bye. Oh, only 2 people got it right.
Oh,
So do you want me to explain it?
we can go.
Never mind.
Find the lines y equals 2, y equals 5, and x equals 1, and x equals a, make a square. Find the product of the 2 possible values of a.
Okay, there are multiple possible values for a.
Now I have another one. Ha ha.
And also, you cannot add up your points. You can only choose the highest one.
Who says?
I say.
Wait, catch
You
the
know
break.
that I'm only doing this for the memes, right? I'm only doing this for the memes.
Well, but you are not allowed to add your points.
Nope, I'm still doing this for the memes.
No, you are not.
Yes, I am.
Can you like kick out 2 of Kester's accounts? It's possible to kick out players.
I don't know how. Wait, let's see. But
Okay.
all right.
Well, my point is still higher than all of your points added together. I made an estimate. That's my estimate. And if I'm correct, I get to be first place still, no matter what.
Find the area of the square units and the area of the shaded region. 10, 10, 10.
I have answer streak 12 now, you know.
Answer streak 12. Each circle is divided into 2 equal areas, and the larger area circle equals 64 pi. Find the total area of the shaded regions.
Someone just say, Mama. This is kind of confusing. But I still got it right.
Called span. The ratio of the length of a rectangle to its width equals 5 to 3. The rectangle's perimeter equals 48. Find the square's area. Joe Biden. Hi. Elika.
So I'm the only one that got 100%.
Oh, Kailstorm.
Yeah, it's one of the new PVC3 plans.
I know. And the runner-ups are both of my clones.
And if you add them up with the calculator. If it's larger than 13,000 UN.
It's half of that. It's half of that.
Congratulations, I defeated you even if you added up all your score. My score is 12,388.
That's
All right.
because I keep misclicking.
Yeah, but the thing is, if you get it right, you get 3 times the score with 3 accounts. But if you get a question wrong, you get
nothing.
Yeah, all of your accounts get nothing. But the thing is, actually, you should, because you have 4 choices and you have 3 accounts, you should like choose 3 of them on every one. There's a 3/4 chance of you getting it right every time.
Actually, I made a 4th account.
A third? Wait, you need 4 accounts?
Yeah, he had 4.
Yep.
Wow.
Okay, we can, so that was Kessler's little experiment for today. But we're at the end of class now. So next class, we're going to be focusing on chapter 19, and we'll have another Kahoot at the end. So everybody have a good night or good morning, good afternoon, wherever you guys are. And I will see you guys next time. Bye.
Bye.